In this video, we will see another example of computing probabilities with permutations. Here's our example. In a horse race with 7 horses, you make a bet by predicting the ranking of all 7 horses. If you place your bet at random, what is the probability you will get the first, second, and third horse correct, and in the correct order? So here is the event that we're interested in that we call sigma, getting first, second, and third correct and in the correct order. So that's what we want to know, that's what we're interested in, and that will be the numerator of our probability calculation. So let's count how many different ways there are for us to do that. So we have 7 horses. So to visualize this, here we have our first place horse, our second place horse, all the way to our 7th place. And we want to know what's the probability that we get first, second, and third place correct. So first, second, and third are correct. Another way to think about that is that there is one option for each of those slots because we got it correct and in the correct order. Now for the remaining 4, how many options are there for our 4th place horse? There would be 4 horses remaining. What about for our 5th place horse? There's 3 horses left. For 6th place, there's 2, and for 7th, there's 1. So that would be 4 factorial different ways for us to get the first, second, and third horse correct in the correct order. So there's 4 factorial ways for our event sigma to occur. Now that's going to become the numerator of our probability calculation. So probability is equal to 4 factorial, and now we have to determine what's our denominator. What are the total possible outcomes or total possible arrangements for these 7 horses and how many ways they can finish the race? So saying that we didn't get any of them correct, we're not asking for any certain event. If we just arrange these 7 horses in 7 places, that would be 7 factorial different ways. Now to show how we might simplify this, remember that 4 factorial is just 4 times 3 times 2 times 1, and that 7 factorial is 7 times 6 times 5 times 4 times 3 times 2 times 1. And then you'll see that 4 factorial cancels out on both of them, so we're left with 1 over 7 times 6 times 5, which gives us 0.00476, so a pretty small number. And if we turn that into a percentage, we would get 0.476% of getting the first, second, and third horse correct in the correct order. Pretty small probability.